Okay. So let's have a brief look at the next thing. Yeah, another amazing thing. So we are not at the end of the day, and we have a next really highlight. So I'm very happy that we have been invited into a research group, in a project group that is managed by the Eclipse Foundation. And we have, there are a lot of large companies with a lot of resources and capabilities to bring technology forwards under the umbrella of the Eclipse Foundation. And one of the companies is Huawei, and others are like Bosch, and we are small Volla. And I am very happy to welcome Mr. Schmidt, who is, how do you say it, engineer of Huawei, and he will present us Oniro, another open source operating system. And one spoiler alarm, it's so exciting because Oniro has a very special approach for operating systems for any kind of device, not only phones, it can be tablets, it can be IoT. And they're working on using a mainline kernel Linux. So it sounds very technical for many people, but it has an impact because if we can manage to do so with that large partners, we may also come to a point where we have all the drivers open sourced and we can make a really free operating system for Europe. That is the scope for Oniro. Thank you very much that you come, and I'm looking forward to your presentation. Here's a microphone.
Thank you. Let me set up here quickly. Okay, so hello everybody. My name is Stefan Schmidt, as Dr. Wörzer already explained. I work for Huawei for the Open Source Technology Center. Oh, what's that?
Microphone is not connected.
No, that is.
It was up.
Okay. Okay, sorry, give me a second. Der Fernseher, oder? Okay. 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 Hopefully it stays this time. Okay. So let me start again. So my name is Stefan Schmidt. I work for Huawei in the Open Source Technology Center. We have our biggest office in Germany is in Munich. I don't work there, I work remotely, but that's where we started. But in general, as a big company, we are spread all over the world, basically. So my main role, so here I'm a principal solution architect, but my main role is really to work on Oniro. And as Dr. Wörzer said, that's an Eclipse Foundation project where we're working together with different partners from different business units, from different countries. It's really depending on where you're coming from and what area you're working in. And we are trying to bring something over which is called, Open Harmony. So I will start a little bit of explaining what is the connection between Oniro and Open Harmony, And then I will explain why we are here, why we are talking at the Volla Community Days, actually. So our idea of having a developer handset based on the X23. I will talk a little bit of the current development status we are having. Obviously, not as much progress as we hoped for, but in general, we have been making good progress there. And we're also talking about the future roadmap we are having with this specific project. So, Oniro. So what we have here is a collaboration project under the umbrella from the Eclipse Foundation. So when we set up this project, we wanted to be in a vendor-neutral environment where we can go and say, look, we want to do business together, but we don't want to have it like one-on-one business where we just have one partner company we're working with. So we want to have like a neutral ground where other partners can jump in and can work together. There are small companies involved in that, which only like maybe 20 or 50 people or maybe a few hundred or so. And then you have big companies like Bosch in there with it's huge, but maybe only specific business units from us or so. But in general, the idea was to have a ground where we can actually work together without too much limitations in terms of where we are competing in other units or something. So we want something there. And given that it's a complete open source project, the best way for us to go with the foundation here. So Oniro itself, what I highlight here, distributed open source operating system. So the idea here is to bring a new mobile operating system out. So it is not based on Android. It is completely something written new, obviously based on open source technologies that are already there. I mean, it would be crazy to start something from scratch for everything. So we're using obviously a lot of components that are there, but then we are enriching that with technologies we develop ourselves or coming from partners and so to integrate that. One of the confusions I often have when starting with this presentation and explaining it to people is what is the relation to OpenHarmony here. So OpenHarmony is the project that is developed in China. It is hosted by the Open Atom Foundation, which is it's a foundation very similar to what Eclipse Foundation is here in Europe. They have like their own GitHub Git hosting called Gitti and so on. They have all the source code there. It's a complete open source system, but mainly developed in China. All the communication is in Chinese and so on. So it's very, very difficult from our side to really get to tap into that, to contribute, to read and so on. And that's a very difficult thing for us. So in 2020, we said, okay, we want to bring that further. We want to get that out of China. We want to show it in Europe, maybe in other parts of the world as well. But we want to start with Europe. And then they said, look, what can we do here? We not only need like translation of the documentation, that is just one step, but we need to build up a community, to build up a network of partners we are having and so on. So that is something that they planned on. And they named that Oniro, basically. So that is a sister project. So that means most of the code and most of the things we are talking about here is also the same for OpenHarmony and Oniro. What we do especially is we have specific additions, specific parts that are needed for either partners here in Europe or have like specific legal requirements or something. That is something, the modifications, additions we are doing here and making sure that we can then work together on top of OpenHarmony here. So just as a starting point, so whenever you see that later here, the OpenHarmony, so all these architecture diagrams and everything, that also applies to Oniro at that point. So after laying the ground here, I said before, it's hosted by the Open Atom Foundation. It's a complete open source system. So all of the newly developed components coming from us or our partners are under the Apache 2.0 license. So that's OSI approved and everything. So it should be easy to integrate in all kind of other systems. Obviously, we have existing open source components that might have different licenses and so on. Biggest example is the Linux kernel. Obviously, it's GPL. So that means you have other license agreements on that. But that is part of when you take these kind of things in. We have a notation of mini, small, and standard systems. That is what Dr. Wörzer hinted on when we are saying, while we are focusing on mobile right now, that doesn't mean that we are ignoring different parts in the IoT space or something like that. So one of the next slides will show you how small these systems can be. So we have an approach where we support different kernels. So the Linux kernel is the one for the standard system. That's the one we would use for the developer handset, or just really rich devices where you have like a big GPU where you can do like fancy graphics and all these kind of things. But we can also go down to very very tiny battery-driven sensor devices that can that would use a different kernel here. That would be LightOS as a kernel in that regard. While normally, if I give this talk, nobody really knows about it. In China, that's already quite a big deal. We have, as you can see, I mean, these numbers are outdated, I'm pretty sure already. We have like most likely over 300 certified products already from over 100 manufacturers and so on. So that's a big market there already, where people have that. Actually, the bigger project on top of OpenHarmony, which is called HarmonyOS, which is the distribution basically from Huawei using OpenHarmony technology and then enriching that with their own proprietary stuff on top of that. That's actually running on handsets right now. So there's a new handset release from Huawei in China that is using this kind of technology in there as well. So there's a big market there, but it's not so much in Europe. So that's something we want to grow basically. So, but if you look, I mean, the architecture diagram for the people that have seen these kinds of things before, it's not too different. It's very similar to other kind of operating systems for mobile you're seeing. The technologies used might be different, but in general, the same context you're having. You have the normal kernel layer where you have like different parts. One thing to mention here is that we had a kernel abstraction layer, so that some parts of the upper layers can work on LightOS or Linux kernel, for example. That is for the different standard, for the different system sizes we are talking about. And then we have something called HDF for Hardware Driver Foundation, which allows us to transfer some of the drivers between the kernels. That's a bit problematic sometimes, but in general, the idea is to be able to develop drivers for specific devices and then bring them over to different types of boards or something if there's a transition from like a mini system to a standard system or something like that. On top of that, we have the normal system service layer. I mean, you have the normal stuff you would expect, like for media applications. You have like things for the normal networking, and all this stuff is just available. One of the things that is more unknown is, or newer in that regard, is that we are working on a distributed aspect here. So we have a distributed scheduler. We have a softbus technology is called, that would work with different devices in your network. So for example, you're at home and you have like your TV and your watch and your mobile, and all of them would be running OpenHarmony at that point. I know it's future, but in that case, these devices could work together. They could share resources. For example, if you want to render something on your TV or something, you could use the CPU or GPU on your mobile phone for that and so on. So these are distributed aspects of that. Not all of them are in working completely right now, but in general, that is like one of the aspects we want to push forward to. On top of that, we have a framework layer providing all kinds of services to the application development and so on. I will come to a few of these later. So again, talked about the different system types here. Standard Linux systems, normally Cortex-A, that is, if you're a bit more into technology, that is like what ARM calls their specific CPU ranges that are more powerful and used on mobile handset and so on. But it goes down to things like Cortex-M, which is really small memory only. There we are using a real-time operating system like LightOS, for example. And these things could all work together with OpenHarmony. Obviously reduced in functionality and features and so on, but in general, the core components should be there as well. I mentioned the softbus already. I mentioned the kernel abstraction layer already, and the hardware driver foundation as well. So especially the hardware driver foundation, that's something that might bite us a little bit in our work of getting like the kernel changed over, but that is part of it. On the application side, what the main push we're having right now is a system called ArcTS. So Arc is a compiler that has been developed by Huawei, and TypeScript is for TS is for TypeScript. It's the actually extended TypeScript a little bit. So we wanted to have that for strict type checking, and I think a few components have been added to make the language a bit more versatile for our approach here. And then we have like a complete application framework built around that to do application development. Okay, so that was just to make sure everybody's at least roughly gets an idea why I'm here, what brings me to the table here. So at some point we looked and we worked on Oniro for a while, but we always worked on developer boards, and then you have connected it to some display or to a HDMI monitor or something like that. But we never really had like a full product we wanted to run it on, right? I mean, yes, company internally, we might have that, but that's nothing we can share with the open source community and we can't work on. So And having things like that are easily accessible, like the Raspberry Pi, is really nice. People can get that really easily, but then you have like the full setup around that, and you wouldn't be able to just have it with you. There's no mobility involved in that. So we looked around and looked what kind of developer handset we can go for. And in China, there are options, but it's not easy for us to just get them over and distribute them here to developers and so on. There's no off-the-shelf solution, basically. So at that point, we stumbled on Volla and said that would be a solution where we could be looking for. It's an existing hardware design. It has proven itself. They have it's a good track record. It's not like a one-time device and then they disappear from the market. They have shown over a couple of years already they have been able to bring out phones, and they have been supporting the communities around that. So that was a good indication for us that might be a good partner for us to go in that direction. And while not doing the complete design themselves, they still have access to specific parts that we might need to get a full port going and really worked out in the end. So that was a good fit for us. So we reached out and see what we can do there. Dr. Würzer, as you can see, is always really engaged and is really motivated to do things. So that was the same when we got into contact here. And so we sat down and see what are our goals? What would be our goals for this cooperation we would have here? And to bring that over, we would need to have a stable board support package for mainline Linux. That is our final goal. We are far away from that, but we are making good progress in that direction at least. We want to have that as a stable base where we can see, look, we have these BSP running. On top of that, we can bring Oniro over. That is expertise we can bring in, and we can put on the device. And at that point, it would be working stable enough for developers to go. Maybe more work would be needed for a complete commercialization, but at least for developer base, that would be good. And we wanted to have it available as a full target in our IDE system called DevEcho Studio, which is like the IDE for the all application development, something. And as with all the normal IDEs you have nowadays, you could plug it in and then it would pop up and then you can do all the debugging, development and all. So we want to have that supported as well, obviously. And for one of the key points for us was to have an easy access, easy off-the-shelf access for developers. They can just go out, buy the phone and get started with development without trying to get from China, have import taxes, maybe not being able to order it at all and so on. So that was a key point for us to have that. And that is a hardware platform that we also wanted to have available for our partners in the Oniro working group. Some of them are more software focused, so they would be happy to have a hardware platform there, can showcase their software running on top of Oniro and so on. So having that available for events or even for their own partners and customers and so on would be a good thing. So that is the big picture, I would say. I will go into more technical stuff going down. So I know it's the last session of the day. Everybody's tired, but please bear with me. And if you're not too much interested in that, then I can't do anything about that. Sorry. Okay. Yeah. So we have been talking about the kernel. Why do we talk about the kernel? I mean, normally I know for people that are looking at from a higher picture or just consumers or something, they don't really care that much. For them, the hardware should just run and be good with it. But for us that are actually doing all the nitty-gritty work below, we understand that these pieces need to work together well and can't just be hacked together and we hope it works in a lab and then we ship it to someone and it's not working at all, right? So we have the situation that with the OpenHarmony and Oniro kernels, we have some specific requirements we need to get. We have a specific set of feature patches we need to get in, and we have specific user space interfaces we need to have working and so on. That's not uncommon. That is basically all kind of vendors are having this. For us, the problem is if we start going with the Android common kernel, which is used on the Volla OS, but also just waiting for the biker to go through. But also for the UB ports, Ubuntu Touch kernel and so on, based on Halium and so on, they use the BSPs provided with the hardware for this specific board from the designer and so on. But for us, that would conflict with kind of some user interfaces we want to have, some user interfaces we need to have, and also the way things like, let's take the graphics system, for example, right? We are not running Wayland. we will have problems with the Harlem approach, how the graphics are exposed and so on. So for us, it would be a lot more easier to go ahead and have a normal DRM KMS-based system or something with 3D acceleration, with MISA and so on. That would be fine. But all of these pieces need to work out before we even come to the stage where we say, this is a good system that we can ship outside the lab. So we looked what kind of options we are having for the kernel. We started to work with Volla. We also got in contact with Kusi Group, and hopefully at some point with MediaTek also, to find out if for this specific SoC, this specific board, if there's an BSP available from them already without with not Android-based but mainline Linux-based. That seems to be not the case. So that is something that is, maybe at some point, if we can work together with MediaTek, that might be sorted. But we are not talking about months here. That's a longer approach, basically. So the other way we could have is to start from the normal mainline Linux kernel that's available, take the existing MediaTek architecture support that's there, and then enrich that going forward with the specific support for specific chipsets, specific power management features, specific all kind of different parts that are needed for this specific SoC. That is a lot of work. Volla is a small team, and also while we are a very big corporation, the team we are working with is very small as well. So that's a point that it could be done, but time-wise, that's a real problem, and we need to figure out if that's possible or not. Right now, the third approach is what we are doing just to get a proof of concept out, just to make sure that we get something to show for, and then hopefully convince more people and also our management to put a bit more resources into that. So we are stripping down the Android common kernel, and at some point we are going to remove some of the user space interfaces that might conflict for us. What we're doing right now is to add more of the functionality that is needed. Things like we have a functionality for high log and some other parts. That doesn't tell you anything, I know that, but it's like specific features we need for the system to run, and we are bringing these kind of patches in right now and see what kind of stuff conflicts and whatnot. But as I said before, our goal would really to go for a mainline solution, mostly because we could align that together with the goals we're having with OpenHarmony, where there's the work is going on the mainline kernel. All the features are developed there, being rebased on new kernels and so on. We can pick that and have a better integration at that point, and really have like a convergence of goals at that point to have that. Avoiding the conflicts with the features and user space interfaces, I mentioned that. But also it would help us to decouple from the Android release cycle. So right now, what we have with ASAP or something, Google brings that new out, and you are eager to bring a new, like Volla S14 or something out. You're bound to what Google is offering you at that point. And that is completely clear, but we might have different goals for different kernel releases, the different versions and so on. And to decouple these kind of, I talk too slow, I guess.
Yeah.
Okay, but it should be. There we go. There we go. Okay. So to decoupling that would also help us quite a bit. Okay, so that brings me to the current development status, what we're having. So we have, when I say we, it's mostly the team, so Francesco and other people. So I'm just standing here. I don't have much time on development these days, but what we're having is Oniro running an LXC container. So first step, all the development work we are doing is on Ubuntu Touch. So we are basing our code on the work we are doing on that. And we have an LXC container that has Oniro in it. And we are using that for a rapid testing cycle to make sure that we can change things there, to make sure that all the system services and everything we are working on being updated quite regularly. So we can work on that instead of doing a full rootfs and then doing a system image and flashing that every time and so on. We're going with a container at that point. We are now at the stage where we can also modify the kernel. That took us a while to get that all sorted out. But now we are in the position where we can bring in patches, where we can do modifications that we need for the system services to run and get that all started. The focus is on enabling all the system services. I don't have a full status on that right now. If anybody wants to see a demo on that, Francesco is here. I'm here also tomorrow, so we can then maybe sit down and we can show it or so. But I mean, showing just a log on the screen or something, I think that's a bit boring. So yeah, we're not doing that here. So as I said, for the kernel modifications, things like high view, high log is a new functionality, new features that we are bringing into the kernel that we need on the system level. HDF, the hardware driver foundation, that is something for the device driver framework that the project brings in. And then for Binder, for example, that is also used on Android, but it's also used on Ubuntu Touch and so on. Oniro OpenHarmony use it as well, but we might have different configurations, how we want to use it and how we need to use it and so on. So yeah. So as I said, right now we are working on the Android Common Kernel with 5.10. One of the things that's on my agenda, it's also on Yami's agenda, is to work on the patches that he has been doing last year to try out what the status is on mainline for X23. We have a regular call with the Volla folks, and there was some effort at least bring something up to see if there's some initial work going on, and that's something we want to verify on the latest kernels and see what the status is there and bring it forward from there. I still owe Yami to test it on my side as well, but I will come to that, I promise. So that is the current development status we're having. But let's also go to the roadmap, what our plans are. I mean, I laid it out in the beginning already, but let's make it clear how I would put that into different phases of the projects we're having. Right now, we are really in phase 1 for the proof of concept. So we go the approach, even if we are not satisfied with going with the Android Common Kernel, we go with that, see what are the roadblocks we are really hitting, making sure we get something out, we can demonstrate and convince people that this is a really good approach and we need more resources and more energy to put into that. That is what's going on. We're doing the patches, we're doing the enablement of the services. Once we have all of that finished up in a way that at least it's running well for us, we will go and create a system image that can then be fully flashed as a super image with boot image and so on, to have like a solution where you have like only a few files, and then you can get the X23 as a full on your phone. That is something I could go ahead and show my managers and so on, and say, look, that could be a result, but we need to put more resources into that. And for phase 2, that is what we are working on in the background as well. As I said, we are trying to also talk to the other companies involved in that, hopefully also at some point with MediaTek, that they might give us support in that regard, because I think they have code available to support that. Maybe not completely fully fledged out or something, but I'm pretty sure that they would have in some lab code available for a normal non-Android based Linux system for their hardware to testing, even for the tests. So all the hardware development stuff, I know they use that at some point in the lab for the bring up and everything before they go for the full BSP development. So we would need to reach the right people and get the buy-in from them. That is basically something we need to work on as well. If we can get to that level and we can get some production ready images for X23, then we could even think about if the interest from the community and from our partners is big enough, if we could have them as a pre-installed option in the Volla shop. But that really depends on a lot of other pieces in between. And on our side, we would need to work on OTA infrastructure to make sure that we can really deliver like different streams, stable, better, even development streams and something like that based on that. But this is future looking. We want to see if we can go to that point, but there's a lot of work until we get there, basically. Okay, thank you. I think that's it for here.
Yeah, thank you very much. It's inspiring. It's very technical, but my brain is already working and I have some associations. Do you know the project Neptune that never came implemented, but it was very pretty successful Indiegogo funding. It was also about connect devices that are sharing resources, and that's inspiring me very much. And it's also somehow related to the initial patent of Volla in 2017 or 18, when Volla started with a big picture of that connected devices. So I think we will have a lot of inspiring conversation also for the future. And I think because of so many huge parties, powerful companies, are part of the whole project, there's some good chance to crack the nut. That is the SoC vendors to bring in on board. With that, yeah, they're looking for.
You need to find a way to make it clear to them that there are business opportunities. They are big enough for them to actually progress.
Yeah.
The same. I need to convince my manager. You need to convince them as well. So that's always the same.
Always the same thing. But I think there's the potential, the option in that story. So that I'm so excited. Okay, so some people have questions. We have also some developers here. Yes, you're here.
About the HDF, the Hardware Driver Foundation, what's its relation to drivers already in Linux kernel, and how does it work how does it actually work then?
Okay, I mean, going into all of the details might be a bit too much. Okay, so maybe going to all of the details is a bit too much, but the idea here is they brought in HDF to have a way of transition drivers between, as crazy as it sounds, between Linux and LightOS, for example, right? So write a driver, it's a different, it's a bit of a mixture of like having a descriptive DSL describing the hardware, like the different registers and stuff like that, how the memory access is done and so on. Describing, I mean, you can, device tree, is that something you're aware of? Like, so you can describe the hardware a little bit, and then you have like stuff around that would do the boilerplate code for like all the drivers. So that was the idea, to transition the drivers back and forth. There's another kernel that is being developed on that's not Linux based, and there's also the idea to have like the drivers going between there. That being said, it is not mandatory for all the drivers to have that. There are for some existing in mainline, or some existing drivers that are already in the kernel trees and so on, there are bridge functionality to expose that to the specific system services we are having to have that. So we have an UHDI, user space HDF component that actually would do the talking to the KHDF HDF component in the kernel to have like the getting access to the different hardware components of these drivers and getting all the functionality. Let's take Wi-Fi, for example, right? So Wi-Fi, normally on Linux, you have the NL 802.15.11, interface that you would use to like configure the network interface and make sure that you can access it. That is on OpenHarmony. They use a different technology there, and that is used through HDF. And to do that for a different Wi-Fi driver or something, at least a couple of years ago, we would need to have like a different Wi-Fi driver. I think by now they have a bridge component that would map it to the existing drivers that are available. So I hope, that's a hope here, right? That we are not bitten too much by these HDF, but we have to see in detail when figuring that out. You're not looking to, did I hit on your question completely? Because you're not looking to satisfied with the answer, to be fair.
Sure.
Okay.
Like, no, I'm correct.
Yeah.
HDF, like, those pods. The abstraction layer, and it has user space part of Harmony OS, your abstraction layers, and then you also have some kind of kernel driver code part, which user space part.
A little bit. In one hand, it's a little bit like that, but also that you would write the drivers in a different way so they can be transitioned to different kernels. That is the combination that the HAL in Android doesn't have. So there's more abstraction in a different way. So, and it's not only about like firmware and driver communication, for example, or so, and to have like the binary blob outside for the graphics driver or something. It's not only about that. It's also different interfaces to the system service. It's a bit difficult to explain in just a few minutes or so. Yeah.
So, like, as I understand it, you have a kernel level framework as well. Harmony OS specific drivers get dealing with this kernel frameworks and convert it to LightOS and to non-Linux kernel.
Yeah.
That's why the Harmony drivers.
And as I said, there's a different kernel also in the works for something called Harmony OS Next, which is the commercial offering from Huawei. And they're also looking into different kernel alternatives. And so they are also looking at it. Personally, I'm not really convinced if that is the best approach, because I normally think transitioning drivers between different kernel things is not really that helpful because, for example, LightOS and Linux are normally not supposed to run on the same hardware because they're too different in terms of like what they're offering, what the hardware requirements are, so on. But if a different kernel comes in that would run on both of them or just on one target, that could be interesting. But yeah, I think I'm happy to talk about that tomorrow again or something. But I think we start to bore a few of the other people. But in general, you got the gist correct. So it's basically the idea is to transition back and forth. You have an abstraction in there, and yeah. Okay. So let's.
So, did I get right that the drivers written with HDF would only work in OpenHarmony, or would they work with other operating systems that also use Linux kernel?
No, only open.
Would there be a way to possibly somehow create a bridge for them to work with other bases than OpenHarmony?
So the code for that is all open source. So you could patch the HDF patch into a different kernel if you in an Android kernel or something like. If you want to do that, that's all there. It's not like there's nothing being blocked or nothing kept behind closed doors or something. But you would need to actually do the development on the kernel side, and then you can bring the drivers over on that part. So that would be possible. Yeah.
Yeah.
Sparking some discussion.
Yeah, just a side thought from me as a Halium developer. So previously, when Android was the dominating force, we had the situation that we had only the Android BSP, the drivers were written for Android, the user space components are all for Android, and the way alternative Linux operating system could survive is by adapting themselves to use Android components, like we do with Ubuntu Touch currently. And if we do the OpenHarmony kernel, we get similar stuff all over again with the HDF drivers, which are open source, but you will need to adapt your software to utilize those HDF drivers. But anyway, like I've looked at OpenHarmony previously on OnePlus 60, and it looks promising there that you use standard Linux components like Muscle Lipsy, Pulse Audio, or I'm wrong. Volla, do you use Pulse Audio?
I would need to look that up. Muscle, no, but Pulse Audio, I'm not sure.
Okay, but Volla for sure. So there could be some nice cooperation like with other operating systems to run OpenHarmony software, for example, if we remain compatible with you.
So to be fair, my personal hope would be that we, as I said, don't have to deal with HDF too much. My personal hope would be that we have enough bridging functionality available that we can just do a normal Linux kernel driver and then have bridging functionality to bring that to the system level components, the services we're having, and be done with that. So that's what I would hope for, having like a full mainline support driver, support for this specific hardware or any other hardware, and then we are good with that, and then we can adapt Oniro OpenHarmony on top of that. So I don't want to have this kind of solution where you're saying we are putting ourselves in a different corner again, where we have like same whole problematic and so on. I completely agree on that on technical level. But we have to deal with reality, what we have right now, and I have to deal with what is coming with OpenHarmony, and I just can push into specific directions. So that is, but I agree with your sentiments there. Yeah, that's question as well.
So actually, as a consumer, why would I prefer to use your operating system over alternatives?
Okay. So I'm not a sales manager. I'm not doing anything. So no sales pitch for me. Sorry. So it's a different approach. It has a struggle right now to have the same ecosystem as Android has, for example. So we are struggling on the application level, obviously. We are coming there. In China, that is pretty good already. In Europe, we have to do more. But that's obviously a point to not sell you the device, right? So as I said, one of the key points we are having is the distributed architecture we want to bring in and have that available to like have more devices working together. So that's one of the key points. That is not really something that is working right now that would be demonstrable to you at the moment, right? But I've seen demos of that in, for example, in a smart home or something where the different devices are working very much together to like enrich each other, either be it on hardware resources or just on sensors or functionality to know a bit more of the context and so on. So that's something, that's kind of one of the unique selling features here that we're having. For the rest, it's really up to you if you want to switch to a different operating system or not. But if you're unhappy with Android for one reason or another, or unhappy with Ubuntu Touch, or unhappy with Sailfish or something like that, there's always like a niche to find and go and look for a different operating system. But as I said, I'm not here to sell that. I'm here to look at the technologies.
About the apps, are there any compatibility layers that would allow me to run usual Linux apps or Android apps?
So there's no, for a while there was compatibility to Android, but that's no longer there. That is something we are not, at least in OpenHarmony. It might be in some of the distributions of OpenHarmony, it might still be there. But for Linux apps, I would need to look if, like, it's not, there's definitely some things in the way to just run it. It's not like your normal Linux distribution where you can just put it on and then compile something and get it working or so. So there's definitely something in the way. So I wouldn't say if you're looking for something as a complete open developer system or something, this might not be the solution you're looking for. I know I'm doing this very bad sales pitch here, but it's, as I said, it's really in the end for the mass market we're aiming for. And in terms of applications available, so the latest numbers I have from, at least from our HQ side, is that from their analysis, like 80-90% of the people that's using have like 5,000 specific apps that are used all across the what they're using, and 4,000 or so of them are already targeted and being available. That might be different data in Europe or North America or something like that, because we have a different way of engaging with devices and so on.
Well,
so
it's surely different. There's no mobile website on Android that will allow me to run my banking app.
okay, so
like some compatibility layer would probably be needed to really adopt for EU mass market.
yes, I mean I don't disagree on that. I just you have to see what is available at some point. If all the ones are available, there will be. We're working on things like React Native and other things. So there is work in progress to not maybe go with a full Android application or something, but all the different frameworks that is being looked into.
If I remember right, Harmony OS has a compiler for Android Java code. So like you make some changes and you're able to compile the Java code to run like this sometimes.
But that is Harmony OS and not OpenHarmony. So again, that's the commercial offering. So they have different features. They might have compatibility to other parts and so on, but I'm working on the open source side here only.
I saw this compiler open source like this available for OpenHarmony.
It is, but I mean, the compiler is one thing. You need the whole framework around it to make sure everything is working completely, and that might not be available or something.
I saw they implemented some of the Android frameworks on that namespace, for example, like.
That was one of the, that was something that was part of Harmony OS before, but that's no longer the case. So that was like a stepping stone to get into the market, to have that all available. But now that we're reaching a specific growth, then that is not longer on the agenda.
Maybe the first movers will also be industry solutions.
Yeah, I mean,
We should think beyond the smartphone. Many people are don't use a smartphone as a phone anymore. and for instance, we have a business partner who is now offering our platform, hardware and software, to the automotive industry, for instance, to have competitive industry scanners. So industry scanners, if you from a distance scan some barcode or QR codes on things, really critical things, during the production process, they're costing up to 2,000 euros, something like that. And this quite cheap hardware of a smartphone with an AI-supported camera app, then you can offer really an industry scanner that is very competitive. This is currently what we're working on. I can't tell you the name of the manufacturer, but this is a special industry product for the for the automotive industry, for instance, an industry scanner. And this is something that you can think of also other use cases, that you have a Linux platform and you can make industry solutions.
I mean, we have something like that. We have you're aware of that. We have like a proof of concept we had together with Bosch working on the Canto system. So Canto is also an open source system on the Eclipse Foundation. And there are a lot of like fleet management and having a way of like bringing your application on the specific hardware and then doing all of the rest in the cloud backend and so on with either Bosch IoT Cloud or other components and so on. So you have the dashboards, fleet management, all these kind of things. These are industrial solutions that are easy to integrate. I mean, that's not a problem. If you want to have like depending on what you want to do, if like you want a customer that is like a normal consumer that want to have like a range of full application space, that's more difficult. But if you go ahead and say like, I want to have an industrial solution for like one full screen application or something, doing something specific, point of sale terminal or something like that, that is not difficult to do.
Mm-hmm. That could be also a boost to get attention, also by the SoC vendors. Yeah, okay. Any further questions? So excited with the discussion. Days forward. Well, so thank you very much for coming.
Thank you.
Yeah, so it was an exciting day. Yeah. Huh? Yeah. Yeah. So. So it was so exciting day. A lot of content. We heard about the Volla tablet. We heard about the Volla Quintus, the Volla Cloud, powered by HoloChain, and a Volla Net powered by BChat. It's so amazing what's going on, and with that small team and with excited people. And this